Good morning, everyone. Today, we'll be dealing with railway and airport engineering. Myself, Professor Manoj P, working as assistant professor. We shall start with railway engineering, geometric design of a railway track. Okay, here the most important thing is with respect to railway engineering, they will be asking something with respect to gauge length, what is the safe speed, and all. Okay, the formula used for calculating the safe speed for calculating the safe speed on curves is when we consider broad gauge or meter gauge on a transition curve, then the formula is v. Here v is nothing but the speed expressed in terms of kilometer per hour. 4.4 square root of r minus 70. Okay, if it is a non-transition curve, then whatever value you get here, 80% of that speed is for non-transition curve. That is zero point 0.8 into the value what you got here with respect to transition curve. Okay, if it is a narrow gauge on a transition curve, then it is 3.65 square root of r minus 6. And for a high speed track, then the equation is v is equal to 4.58 square root of r. Normally, we will be using this equation and this equation. When they ask for a high speed track, then we will be using this equation. Here, where r is in meters, that is radius. R represents the radius will be in meters, and v represents the speed, and it will be in kilometer per hour. What do you mean by super elevation? You have dealt with the super elevation with respect to highway engineering. Okay, here also super elevation means the same with respect to two railway tracks. Okay, super elevation. What is the relationship between super elevation, gauge, speed, and radius of the curve? Here, E represents the super elevation, and V represents the speed. Capital G represents the gauge. R represents the radius. You can use any of this formula. E is equal to V square into capital G divided by small g into R. Uh, Here, G is nothing but the gravitational. If we want to find out E without the value of G, then it is capital V square uh, into capital G divided by 127 into R. Here, in this part, V is in meter per second. In this part, V is in kilometer per hour. And also, the value of G is also equated here. So, we get the value of capital V square into G divided by 127 R. And what is with respect to, if you want to express in terms of centimeter, then it is capital V square G divided by 1.27 R. Where E is the super elevation, small v is the speed in meter per second, and capital V, as I said, in kilometer per hour. Capital G is gauge length in meters. R will be radius in meters. Now, this is very important for calculation purpose. What is the value of G? Okay, what will be the value of G? Okay, there are different types of gauges as per Indian standard. One is broad gauge, the second one is standard gauge, meter gauge, narrow gauge, and light gauge. Normally, we will be using the broad gauge railway track or meter gauge railway track or standard gauge railway track. In question, they will ask you whether you are supposed to find out for broad gauge or a meter gauge. If not, you are supposed to find out for broad gauge only. The value of G for broad gauge is 1676 mm or 1.67 meters. Standard gauge 1435 mm or 1.435 meters. In meters 1000 mm or 1.00 meters. Narrow gauge 762 mm or 0.762 meters. Light gauge 610 mm or 0.610 meters. Now, what type of questions will be asked with respect to railway engineering? Okay, what is the transition curve? What type of transition curve is mostly used by the Indian Railways? Okay, option goes like this: circular, spiral, cubic parabola, or cubic spiral. Okay, here transition curve, as you know, curve will be of different shape. For Indian Railways, we will be using the cubic parabola as the shape of the transition curve. So the correct answer was cubic parabola. Maximum allowed cant deficiency value for a broad gauge track prescribed by Indian Railways. Cant here represents the super elevation. Cant deficiency is the amount of super elevation which is deficient. Okay, what as per Indian Railway standard, what is the maximum allowed cant efficiency? It is 0.075 mm or 0.075 meters or 75 mm or 7.5 centimeter. 1.5 centimeter or 75 mm or 0.075 0075 meters. The gradient of a railway track laid on a valley is an example of what type of gradient? This is laid on a valley. Okay, is an example of what type of gradient? Here this is a valley curve. You have learned what a valley looks like. Okay, valley curve. Here the rail will be traveling at this point. This is the lowest point of the curve. Again, in a valley curve, the gradient will be upward. So the train or rail, okay, it will gain its own momentum so that it can claim the curve, it can claim the gradient. So this type of gradient which is provided is an example of momentum. Since it gains momentum so as to claim the gradient, so we call it as momentum gradient. Maximum degree of a railway curve for a broad gauge track is restricted to how much? In a broad gauge track, here the degree of curve, that is okay, the degree of curve provided here, it is restricted to 10 degree. The length of transition curve depends upon what? Okay, in order to calculate the transition curve, okay, it will depend upon, in order to calculate what is the length of the transition curve. Okay, here we need cant efficiency. In order to calculate, we need cant excess and also we need permissible speed. So the correct answer is, okay, we since we have the cant efficiency, we don't need the cant excess. How much amount of super elevation we have in excess? Okay, mainly we need cant efficiency. We need the actual cant. What is the actual super elevation and what is the permissible speed? So the option is 1, 3, and 4. Theoretical current can be achieved by the following relationship. Here we have the relationship theoretical current is equal to equilibrium current plus current deficiency. Theoretical means the one which you get using the proper values. Okay, equilibrium current plus current deficiency. What is equilibrium current? Equilibrium cant is the one which we are using the standard values. Cant deficiency, yes, when there is a deficiency in the super elevation, then that is known as cant deficiency. When you add both, you will get the theoretical cant. Negative superelevation. What is negative superelevation and how do you calculate negative superelevation? What is the equation used? Negative superelevation is equal to equilibrium cant minus permissible cant deficiency. Okay, this is a small one marks question. They ask maximum gradient for a railway station yard specified by Indian Railways. You know, in a railway station yard, the gradient should be almost flatter. Okay, even though when you provide gradient, it should not exceed more than 1 in 400. So the correct answer is option A. The correct answer is option A. Okay, it should not exceed 1 in 400. So the maximum gradient is 1 in 400. For a broad gauge railway track on a horizontal curve of radius r in the equilibrium cant E required for a train moving at a speed of v kilometer per hour is how much? 1.69 v square by r, 1.319 v square by r, 0.80 v square by r, 0.60 v square by r. So, what they have asked you to find out curve of a radius equilibrium. They have asked you to find out the value of E, equilibrium cant E. Where the equation is for super elevation or equilibrium cant is capital G V square divided by 127 R, or V square into G divided by 127 R, which the equation which I showed you. Here, they have given you broad gauge. They have given you the broad gauge. For a broad gauge track, as I said, it is 1.676. This will be in meters. Okay, this will be in meters. So since your R value will also be in meters, you will get a proper value. 1.676 into capital V square divided by 127 R. Okay, you will get the value of around E is equal to 1.319 capital V square divided by R. Okay, this will be okay. Fine. Look here. This 0.01319. This will be in terms of meters. This will be in terms of meter. Okay. Here, what they have done, they have expressed this in terms of centimeter. Super elevation in terms of centimeter. So that this multiplied by 100, you get 1.319 centimeter. What will be the compensated gradient? Look here, this is for 2 marks. Compensation, what compensation is provided? What will be the compensation gradient for 5-degree curve with 1 in 150 rolling gradient? Okay, compensation means, look here, as far as possible, the track should be flat. If the tracks are not flat, if the tracks are not flat, especially at the curves, especially when you have the gradient, then how do you compensate? Look here, here 1 in 150 is the ruling gradient. 1 in 150 is the ruling gradient. 1 in 150 is nothing but 0.66. Compensation to be provided for a ruling gradient, okay, is nothing but 0.04 percentage multiplied by degree of curve. Here, what is the degree of curve? Degree of curve is 5 degree. 0.04 percentage of this 5 degree, that you will get 0 point, that you will get as 0.2 percentage. Okay, and what will be the compensating gradient? Here, out of 0.66, this is the ruling gradient. Okay, especially at that particular curve, especially at that particular curve, you are supposed to reduce the gradient. To what extent you are supposed to reduce the gradient? You are supposed to reduce this compensating gradient of 2%. That means you are supposed to reduce it by 2%. So 0.66% minus 0.2%, you get 0.46%. So the correct answer is the compensated gradient. Initially, the standard is 0.66, but you are supposed to reduce it. Okay, so it is 0.46. The steepest gradient provided for a 2-degree curve is what? Okay, here, sorry, the steepest gradient provided Here his 1 in 312 for broad gauge track. What will be the ruling gradient? They've asked. Okay, whether the ruling gradient is 1 in 300, 1 in 250, 1 in 200, 1 in 225. Here, with respect to this 1 in 312, you get the value as 0.32 percentage. This is already a compensated gradient. Okay, compensation given for the 2-degree curve is 0.04 multiplied by degree of curve. Okay, this will be expressed in terms of percentage. So this is 0.08. Compensated is 0.32. Sorry, steepest gradient provided already after compensating is 0.32. Okay, compensation which you are providing is 0.08. Using the same equation, you get 0.32 plus 0.08, you get 0.4 percentage. So the value is 1 in 250. So the correct answer is B. Both for this question as well as that question, the equation remains the same. Ruling gradient is equal to steepest gradient plus compensated gradient. When you want to find out the steepest gradient, then it will be ruling gradient minus the compensated gradient. Again, 2 marks question. What will be the extra pull required for a train of weight W to rise up a gradient of slope theta? This is very simple. Okay, here W into sine square theta, W into cos square theta, W cos theta, W cot theta. Okay, in order to have an extra pull, the equation is W tan theta is the extra pull required. What is tan theta? Tan theta is nothing but 1 by cot theta. Here, the question in the question, they have not mentioned what W tan theta, but they have mentioned W by cot theta. So the correct answer is option D, W by cot theta. Next one, if a curve of 7-degree bifurcates from a 4-degree main curve in the opposite direction of a broad gauge yard, what will be the superelevation for a permitted speed of 40 kilometer per hour? Okay, here equation for superelevation is capital G V square divided by 1.27 R. This will be in terms of meter, 1.27 R meters. Okay, G value is 1.676 and speed is 40 square divided by 1.27 into R. Here, R, the equation for calculating R, when you don't know, the value of R, okay, when you know only the value of D, that is degree, that is equal to 1720 divided by 1720 divided by the value of D. Here the value of D is 4. Okay, here it is, since the value is in denominator, this is shifted to numerator. Okay, here you will get 4.91. Okay, here this 7-degree curve bifurcates from a 4-degree main curve. Okay, 7-degree curve is for minor curves, minor track. Main track is 4-degree. So we are calculated for this 4-degree only. Okay, in order to confuse you, they will give you the bifurcated curve also. This is not required for calculation purpose. Only thing is required is the one which you use for main curve. So get the answer as 4.91. Option A is correct. These type of questions they will be asking for railways. Now we will move on to airways, airport engineering. Okay, what is the basic length and corrections? Okay, it is assumed that airport altitude will be at sea level, that is mean sea level will be equal to 0. Main assumption. Temperature is standard, that is 15 degrees. Standard, if they ask you what is the standard temperature, then it is 15 degree. What is the standard altitude? Then it is sea level, mean sea level. Runway is level in longitudinal direction. Okay, the runway will always be level as per their assumption, and no wind will be blowing on the runway, and also no will be blowing en route to the destination. All these are the assumptions. We need to make corrections while designing a runway, while calculating the basic runway length and corrections. And also, as per their assumptions, aircraft is loaded to its full capacity. Okay, that means it is not empty, it is not half filled. Okay, it is loaded to its full capacity. Look, I'll tell only the important thing. Okay, in a normal landing case, there are three cases. One is normal landing case, next one is normal takeoff case, and engine failure case. In case of normal landing case, okay, it required uh, aircraft should come to stop within 60% of the landing distance. Okay, a full strength payment is provided for the entire landing distance. This is normal. Normal takeoff case, yes, the clearway should not be less than 150 meters, and it should be kept free from obstruction. That is, even while taking off, there should be no obstruction. Okay, and the ground area, the clearway ground area of any object should not protrude the plane upward at a slope of 1.25% from the runway end. That means at the end of the runway, there should not be any object which is protruding 1.25 percentage of the slope. In case of engine failure, assume that engine has failed at a speed less than the designated engine failure speed. Okay, by pilot, what he can do, he can deaccelerate and make use of the stopway. If engine fails at a higher speed than the designated speed, then there will be no option for the pilot except to continue to take off. Okay, pilot take a turn. After he take off, he will take a turn in a turning zone and land again for normal takeoff. Okay, this is in case of engine failure case. Some theory questions may be asked, but very less questions will be asked with respect to these three cases. Yeah, with respect to this, yes, 90% of the chance that the question will be asked with respect to correction for elevation, temperature, and gradient. Both the theory as well as the numerical problems will be asked on this. As the elevation increases, the air density reduces, okay, which in turn reduces lift. If it is assumed that the runway is at flatter ground, okay, 0% of elevation, but yes, runway will not be at the mean sea level. Runway will not be at mean sea level at all places. Okay, for airport at elevation above the sea level, what you are supposed to do, the design runway length is 300 feet plus minimum is 300 feet for 0 mean sea level plus 0.03 feet for every foot above the mean sea level. Okay, that means if I have means if the airport is located at a mean sea level of 100, then 300 plus 0.03 into 100. ISO recommends, International Civil Aviation Organization, it recommends the basic runway length should increase at a rate of 7% per 100-meter rise in elevation over the mean sea level. This is expressed in terms of meters. For every 100-meter rise, 7% should be increased from the basic runway length. Assume that we have calculated the basic runway length at mean sea level. Okay, if it is 100, if the mean sea level is 100 meters above the actual sea level, then 7% should be increased from the basic runway length. Correction in temperature, yes, we have assumed that the temperature is uh, 25 degree or 15 degree. Okay, with reference to the same, here first we'll calculate the reference temperature Ta plus Tm minus Ta divided by 3, where Ta is the average mean monthly, sorry, average daily temperature, that is mean of monthly average. Tm represents the maximum daily temperature. A represents the average daily temperature, M represents the maximum daily temperature. The mean for a month is taken into consideration. Okay, ISAO, International Civil Aviation Organization, it will recommend that the basic runway length after having been corrected for elevation. In the previous section, I discussed about elevation. Okay, the corrected elevation you will get. Sorry, corrected basic length you will get after making corrections. With respect to that, again you need to further increase at a rate of 1% for every 10-degree increase of the reference temperature. First, we'll calculate the reference temperature. Okay, then for every 10-degree increase, you are supposed to increase the runway length by 1%. If both correction increases more than 35%, then uh, again recommendation should be given. Okay, again the site study should be done, recorrection will should be done. Temperature less than 15.6 degree or minus 15.6 degree below the mean sea level, correction is 0.0065 degree Celsius per meter. Okay, if they ask you a simple single digit single marks question, how many percentage should be increased for every 10-degree increase in the reference temperature, then you can say 1%. What is the equation for calculating the reference temperature when TA is given, average daily temperature, and maximum daily temperature is given? Then this can be done. Okay, and what is the maximum percentage recommended by ICAO when we consider both corrections? Then it is 35%. Okay, also simple questions, one mark question can be asked and you can answer. And next is correction for gradient. After having corrected for both elevation and temperature, we need the correction for gradient. ICO will not recommend any correction, they have not recommended, but Federal of Aviation Authority, they recommended the correction that it should be 20% for every 1% increase in the effective gradient. What is effective gradient? The difference between lowest point and highest point in a runway divided by length of the runway. Lowest point, highest point. Okay, assume that this is the lowest point, this is the highest point divided by the length of the runway will give you the effective gradient. Now, based on those three corrections, you will be having numerical problems. According to ISO, the basic runway length increase for every 300 meters should be at what rate? Okay, ICAO, the basic runway length increase by what rate? I already discussed that it should be 7%. According to FAA, not ICAO, FAA, the orientation of runway should be such that the crosswind component should not exceed how many times? So this was not discussed. It should not exceed 95 percentage. The crosswind component should not exceed 95 95 times percentage of times. Crosswind runway is recommended when the wind coverage is how much percentage? Yes, when the wind coverage is less than 95%. This is the same question which was asked here. It should not exceed 95 percentage time. It should not, I mean, it should be less than 95 percentage time. Total correction factor for elevation and temperature should not exceed how much? Total correction factor. Yes, this was also discussed with respect to correction. This was also discussed with respect to the correction. It should not exceed 35%. It should not exceed 35%. Windrose diagram is based on Windrose diagram is based on orientation of what? Okay, Windows diagram is for calculating the runway length, all those things. You need what method is used? We need a Windows diagram. Okay, it is based on the orientation of true north. We speak with respect to true north. Okay, here when the runway mentioned as 927, runway called 927 is oriented in which direction? What does 9 represents and what does 27 represents? Okay, 9 represents 90 degree and 27 represents 270 degree with respect to north. Okay, 9 represents 90 degree and 27 represents 270 degree with respect to north. Okay, here 9 means 90 degree and since 270 means it will be, yes, 90 degree towards south west. Since it will be at lower point, then it is south. Since it is at higher point, then it is uh, west. 90 degree means starting from the north point, assume this as 0, this as 0. 90 degree means the runway will be here, this will be north, and 90 degree east. The runway will be north, 90 degree east. So it is represented as 9. This will be represented as 9. Okay, and another will be located at south, 70 degree, 90, 180, and 270. South towards west. So this will be south 90 degree west. This is a 2 marks question. Can have a look into it, as it is a big question for 2 marks, but very easy to calculate. The runway is being constructed in a new airport as per the International Civil Aviation Organization recommendations. The elevation and the airport reference temperature of this airport are 535 meters above the mean sea level. Look here, this is 535 meters above the mean sea level and 22.65 degree respectively. Temperature here is 22.65 degree respectively. Consider the effective gradient of a runway as 1%. The length of the runway required for a design aircraft under the standard condition is 2000 meters. Within the framework for applying sequential correction as per the length of the runway after being corrected for temperature is how much? Okay, we'll discuss this. Look here. First, we'll make correction for elevation. Then we are supposed to make correction for temperature. Then we are supposed to check the correction whether it is exceeding 35 or not. Okay, as discussed, correction for elevation, it is 7% increase for every 300-meter rise. So 7% is 7 divided by 100. For every 300 meters rise means 1 divided by 300 multiplied by 535 meters. It is elevated. Look here, 535 meters. It is elevated. Multiplied by basic runway length. Initially, for a mean sea level, the basic runway length is 2000. Under standard condition, it is the runway is 2000. So after making the correction, this is the correction required. That is, you are supposed to add this to the basic runway length 249.66. So 2000 plus 249.66, you get 2249.66 meters. Then you are supposed to make correction for temperature. Okay, since the standard temperature is 15 degree. Okay, here in question the temperature given is 22.65 degree. Okay, so for every 1 degree, first we are supposed to calculate the standard atmospheric temperature. Okay, 15 is the degree is the standard atmospheric temperature, minus for every 1 meter elevation you are supposed to multiply it by 0.0065 into 500 meters it is elevated above the mean sea level. So this standard atmospheric temperature is 11.522 degree. But here instead of 11.522 you have uh, the temperature at that particular place is 22.65 degree. So you are supposed to make correction. What will be the increase with respect to 11.522 and 22.65? It is 11.127 degree. It is 11.127 degree. So for every 1 degree rise, you are supposed to increase it by 1 percentage. So 1 percentage here represents 1 divided by 100 multiplied by this rise in temperature 11.11127 multiplied by the corrected length after you get from the elevation part. So you will get the correction as 250.320 meter. So you are supposed to add this 250.32 meter with respect to the corrected length after you get from elevation. So 2249.66 plus 250.320, you get 2499.98. This is the total corrected length after doing correction for elevation and temperature. So check for correction. Yes, when you check, you get less than 35. So the option is equal to 3 meters, 2753 meters, 2500 meters, and 2496 meters. You get the answer as 2499 meters. The nearest answer is 2500 meter. So the correct answer is option C. Correct answer is option C, 2500 meters. Yeah, from the following data, determine the clear way for a normal takeoff. Lift off distance is 2200 meters. Distance to reach 35 feet. Height is 2632 meters. Here, this is very easy. I think this will not be taught in textbooks. Takeoff distance, in order to calculate takeoff distance, that is 1.15 multiplied by the distance to reach 35 feet height. So that is equal to 3026.8. Clear way distance, the equation is 0.5 into takeoff distance. TOD represents the takeoff distance. Okay. And minus 1.15 is the lift off distance. LOD represents the lift off distance. So takeoff distance you calculated here minus 1.15 into lift off distance. You will get the clear way length required. So 248.4 is the correct answer. This equation I want you remember, it will be easy. Only a simple calculation, one step or two step, you'll get 2 marks. Determine the length of a full strength payment for a normal takeoff case for lift off distance of 2200 meter and D32 takeoff distance. Same question, but asked in a different manner. Okay, this is the distance for takeoff of 35 feet is 2632. Okay, so clear way distance is 248.4. Okay, here they asked you to calculate the length of full strength payment for normal takeoff. Okay, in the earlier question they asked you to find out only the clear way length. Clear way length. First you will calculate the clear way length. Okay, clear way length. This is in terms of meter. Then full strength payment distance. Okay, or full strength length of full strength payment is equal to takeoff distance minus clear way. Takeoff distance here is yes, you will calculate 3026.8 minus clear way distance is calculated from the equation 248.4. meters. So this should also be expressed in terms of meters. So the correct answer is 2778 meters. Okay, this completes uh, the transportation engineering part, that is highway part, railway part, and airport engineering. Thank you. If you have any questions, queries, you can mail me at manoj.p at vvc.ac.in. You can contact over there. If any queries, I'm ready to clarify. I'm happy to clarify. Thank you.